Hi, everyone. Thank you for having me. My name is Ariella Sasson. I lead a team of specialist solution architects at AWS, Amazon Web Services. We focus on healthcare and life sciences and helping them achieve their goals around data and AI. So this is a huge topic. My background is high throughput computational biology. I have a PhD in computational biology and molecular biophysics. I did my PhD in genomics. I worked on questions for the NIH, such as, can you use genomics to diagnose disease? When I started, right, a little bit after the Human Genome Project and the next generation of sequencers came out, um, those were the types of questions we had. Can we use it to help people, or is this data good enough? What does the informatics look like? What does the computing look like? And in the past, I don't know, 15 to 20 years of my career, the answer is yes. We diagnose cancer, we diagnose rare disease in children. We've seen whole new modalities of omics, like the previous speaker spoke about. And so I try and help my customers achieve not only insights into the science to help further patients' lives, but really I aim to help them manipulate data at a scale where we can really achieve personalized medicine. So I'm here to talk to you about what we're seeing in AI/ML. You'll see a lot of names of AWS services that you'll see. That's just the slides. But like a lot of cloud providers have this, a lot of people doing AI and ML. The goal is to help people um, basically do the most with the data they have and gain those efficiencies to help them achieve their goals. So today I'm going to talk about why should you care? I think the previous speaker spoke a little bit about that. Really what we're seeing across many of our customers are data challenges, which underpin literally every AI/ML problem that we deal with. Because you can't answer these questions and take advantage of AI/ML unless you have the data. We're going to look at where AI/ML is hitting inside various companies. And finally, we're going to just talk about some lessons learned and things to be aware of as you implement AI/ML at scale. I don't know. So really what I truly find fascinating about AI/ML is we are adopting it faster than any other technology that we've seen before. Faster than personal computers, faster than cell phones. I remember having a personal computer as a kid, which is probably going to date me, and not all my friends had it. I remember cell phones coming in and how it changed everything. Sequencing was very similar when sequencing came out with the next generation sequencing machines. Everybody got one. It was really changing the way how we think about medicine. AI/ML is faster than all of those. It came in, it landed, it made a splash, and it's really being built in. And every company and every person I talk to is like, how are they going to use AI/ML to make impact, right? To drive their business, to drive patients' lives, to drive the science, to drive efficiencies. How are we really going to do that? And the answer is different for different companies. Some are build training models, and they're seeing huge advantages of that to accelerate their R&D times. Others are seeing it as can we use coding assistants to simplify coders' lives in healthcare? How can we make people's lives easier when they're on vacation with ChatGPT, right? It pulls in information. You can say, I'm going to spend 2 hours in the north of in Volos, Greece tomorrow. What should I see during those 2 hours? Is there anything I should skip? So these are ways it's helping us in our everyday lives. So why should I care? It's making people work better, right? Here's a top biopharma. I'm sure you'll get the slides later somehow. There's a link. I suggest you watch the video because I helped work on this. And I really want to say the hype is real. What this does turn 43,000 hours of work by saving 5, 10 minutes, an hour a day across multiple people, they can now achieve in 1 to 2 days. And really what I want to say about, and this was with agents, they built a small agentic proof of concept to test it. And now they're building version 2, which is much bigger. What I really want to highlight here is why is agents powerful in this? This was a research agent around asking early asset R&D identify new targets in a pharma company. What I really want to say is what this does is allow people to do deep work better, right? You're not distracted by your phone. You're not distracted by 50 papers open in your tabs. You're not distracted by now that I have an interesting target, I have to go to this other website by NIH, NSF, identify those targets on a cell membrane, bring it back, and then try and keep my train of thought after being distracted by my 150,000 tabs and whatever advertisements are on the side. What this allows is a chat interface where you can stay in that work type and ask questions of the data and allow your brain to do that creative thinking. It took a little while for me even to like mull over this information. What makes agents different than LLMs? What now it seems trivial, but what this does is take advantage of what we do naturally when we want to be creative and make big impact. You see this for any of you who have coded before, you sort of see this if you've coded like larger projects. It takes about a half hour to remember where you last left your code. Then you work for a while. And then if you have to go somewhere, you kind of go out. But the next time you have to pick it back up, you need that half hour or 20 minutes, whatever it is, to reassess where you were and let your brain start to work in that space. Agents fixes that. And we're seeing powerful impacts across really all of our customers and across all industries. Another example is this is a quick movie. I'm not sure you can see it, but really what it is these are the developer agents that are helping. You have Copilot, we have Amazon, QCLI, we have strands to build agents. But really what these are ways to allow you to just develop and in this case, manipulate your AWS environment without ever having to go and open the console. You can use this to build code and then action on it in the cloud and kick off clusters if you needed to by building cloud formations and just saying, run these bring in the workflow into our genomic systems, and then say, run it now with this sheet of data, and let the omics service basically do the work for you by building the managed HPC. What's really interesting, this is around genomics. You can create profiles for the genomic CLI with additional information to help it make less errors. It's really good on its own. The QCLI also makes mistakes, but then you can say, hey, this didn't work. Why? And it'll go look through the logs, it'll figure out what the problem is, and it'll fix it for you. What I want to say about this, about like using QCLI, is we're seeing impact today in the field of computers. My daughter is a freshman in college. She has friends, she's at Rochester Institute of Technology. She has friends in the computer science school. They're not hiring. There are no internships. And it's because this is taking over that junior coder. So it's like, who do you know? What can you build? The question now becomes, how do you use this to accentuate yourself? And so you will be now an asset into those environments. Eventually it'll stabilize. You have to train your senior programmers, but what it does is also change the way you think about code. You're no longer sitting there going to Stack Overflow and being like, hey, how do I make this call to this particular type of instance or particular variable? What you now do is you say, hey, I need to build this system with a prompt, help me, and it takes care of the syntax. What you do is take over now like a team lead type of role, and it's a different way of thinking. The best practices around coding still hold. That's how you debug. That's how you help your code helper debug. But what it does is it changes what, and I did this with a customer like 2 weeks ago, what it live on a demo. Like we moved a pipeline from a GitHub repo into the Health Omics, which is a particular service. We took what might have been 2 to 3 days of people programming, putting it into Docker, submitting it to the repo, and then we did it in 50 minutes. We got 80% of the way there. this really accelerates through the fun of coding, but through the grunt work of coding. Your creativity around building the code, telling it what to do, building the grander scheme, that's generally what's fun. Hitting your head against the wall to figure out why my loop has become an infinite loop. That's not always so fun when it's like for several hours. But what this does is it helps you get at that. You can say, hey, I now ran into the infinite loop. Everything worked before. What's going on? It'll say you put a semicolon in the wrong place. It'll be like, oh, that would explain it. So I just want you to think about, like, my take home message to you for all of this is really play with it. You could go to QCLI now, install it, and ask it to like build you a build you a little computer app, right? You want a GUI, you want a little backend that can add numbers together, subtract numbers together. You can literally do it in 15 minutes. I've done it. Um, it's pretty amazing. It really changes how you interact with the space. It changes how you think about what you need to build. And that's where we are. Everyone's trying to figure that out. And what I do say is be aware of this. For hiring, I have a friend who was going for a job not involved in AI. And he ended up getting the job anyway, but his resume was initially put to the side because AI wasn't in his resume. So it's go and play and explore and start to think about it, because it really changes how you interact with your environments and what you want to build. It allows you to think bigger. It allows you to think across the gamut of what you want to do, because ultimately the more data you can manipulate, sometimes you can find those hidden insights that everyone's been looking for. And so when we talk about generative AI, we look at the top of an iceberg, but really underlying all of those generative AI are the data foundations. We talk about unstructured data and how's the storage. What's the latency of the storage? What's the governance requirements? What are you thinking about security? How is your structured data set up? Do you have the metadata to even find it? Are, is all your data harmonized? Do we need to harmonize it? How is the data getting integrated together? And so these are the things we think about when we take on projects around AI/ML, even in like a prototyping 6-week sprint. Much of the work is actually around the data, understanding what it is, how it needs to be used. It's not necessarily about the guts of training models. And it's your differentiator, right? We are in the zettabyte era. We have customers. It's funny. Sometimes I talk to customers and they're like, we have 30 terabytes of data. I'm like, oh, you guys are so cute. Most of my customers are dealing with hundreds of petabytes of data that they've accumulated over decades. If not, some of them have been around for centuries. Um, some of it's valuable, some of it's not, but they want to make optimal use of all their data. Historically, it's been run an experiment, collect the data, and then it's dead. But now in an area of, if you create the right data models and data products, you can reuse this to ask questions and not actually spend money on experimentation, because you have data that can get you at least a peek into what you want to see. And so I come from healthcare and life sciences. And so we have the additional problem of huge amounts of modalities of data. They don't necessarily talk to each other. They're not easy to harmonize. They're, in the case of omics, they're different snapshots in time, maybe different cells, maybe at different points in cycles. So how do you harmonize the data so it's useful to answer questions around dynamic systems um, with static data? And so these are the type of questions we're trying to help our customers even answer, because they're all generating tons and tons of data, and trying to figure out if the data they have generated historically can help them answer questions. If the data that I have now and I bring in other sorts of data, can they fit together, whether it's clinical or on the research end? And what's really interesting about multiomics data is historically it's been very siloed. Proteomics data is very different from genomics data or transcriptomics data. And so you would know about the data you have, you might not know that other data exists in like the same trial or in the same experiment in a different modality. But the questions you can ask when you know that data is kind of paired together is very different. So knowing and finding the data is a really big deal. So many of our customers are looking at investing the time and effort because it is a big lift to go on the journey of creating like a data mesh, data fabric type data set. So data is at the very least in healthcare and life sciences findable, but the idea is it's findable, accessible, interoperable, and reusable. These are the key things that our customers want to do in order to like make the data live, because living data is valuable data and it allows you to be creative and generate new insights because you access the data that you didn't know you had before. And so we see this with our customer Gilead. Gilead started their journey like at this point 2.5 years ago. There's a really nice talk at reInvent around it, where they spent 2 years building out their data mesh around specifically they wanted to focus on their clinical trials, and they spent a lot of time focusing in on that. And now they're not even fine tuning or training their AI ML models, but they are using AI MLs to help accelerate the whole clinical trial process. And they have a list of use cases, and now that their data is in a way that they like, they can pound through those use cases, which is actually accelerating the number of clinical trials they can bring to the FDA and start and impact patients. So investing in your data, investing your time into this space really allows you to accelerate through to the goals that you need. We see this at Sanofi is another one. They reduced 6 months for predictive analytics down to developing it in 1 month, and now they can go through their goals. We saw it at Genomics England, where they learned how to organize their data and now they're building cancer models on the enormous data sets that they have. It is very powerful to get a handle on your data, because that's where then you can be creative on the data and look for those insights. And that's also where deep work comes in. Your brain works on thinking about those connections, and the next time you go to it, or you start going down paths and explore the edge of what you're trying to understand. And so a lot of our customers come to us and talk about, how do we build Gen AI applications? And the truth is, we meet them in many, many different places. Um, we have those that really just they want to use it. So they want to easily build dashboards, or they want to code something. They're really using um, Gen AI applications to help them be more efficient, achieve lower the logistical burden. These are things that help drive business forward and accelerate that work. Then we have those that are building the Gen AI applications, right? How can we access LLM so we can create this chatbot that can work with the agents in the back end? Next, we have people that are building the models, right? So we have services that make it easier. We have access to GPUs. We have access to our own chips to help build models and run inference. So this is where a deeper level of expertise comes in. And finally, the data foundations underlie all of it. What is, again, I will point out, like, those data foundations and easy access to the compute layer is key. So not only does Amazon or really any cloud provider bring the data access to the compute relatively easily, it brings us usually a secure environment that you help build in order to access it, to try and keep the data secure. This is a partnership. There are pieces that you do around security and the pieces that we do around security. And so we work together in order to create the best applications we can. And so what we have here is, we helped Genomics. This is part of the example I gave before around Genomics England. We basically showed them how to use SageMaker on the data that they had in their environment to train models. It took them a little while to get used to the environment. This is managed ML ops. They had people that understood how to train models. And so this just gave them the power to quickly and easily train the model that they wanted and answer the questions that they were looking for around their space. And so once they did the first proof of concept, they took it and ran with it and started creating new exploratory research around it. What I do want to say around this is what's super interesting about building models, especially think about the customers that are building the largest language models. Who are the people that who are building their models? Who are the people like working on the systems and the infrastructure? It's the HPC people. Like the people that I know that are working on to manage their own systems, worry about the latency of storage, worry about which compute types, worry about all the nodes speaking together. These are classic problems that our HPC has been dealing with for decades. So my favorite HPC people at Amazon and externally are basically now all managing large model training runs. So it's very interesting because when you get down to those discussions at the deep core, you're ripping open the box and you're talking about what's the networking card? How are the GPUs aligned? Is there enough data data throughput between the cores to achieve it? It's basically the same classic problems we were talking around HPC all the time. And so those are the people, they've just moved from like running large HPC computational questions, whether it's genomics with naively parallel or oil and gas modeling the earth, they've moved it into self-managed frameworks. All of that knowledge, the people I go to around the complex training models are all ones that grew up learning HPC. And I think these are keys because at the bleeding edge, you're always going down to the infrastructure. I was in a conversation where we were talking about the Amazon chips versus the GPU chips. And it came down to, oh, this model won't be able to be trained on Trainium because the floating point number wasn't where we needed to be. And so that's where it starts to get interesting. It's been a while since that conversation, and Trainium and Inferentia have come a very long way, so they're going to revisit it. But when you get down to those like really cutting edge training, novel models, we're ripping open the infrastructure again and going down to the deepest levels in order to understand what's going on. It's not everybody that does this. Most people will not touch this level. Of all the customers I know, I have a handful that are really like ripping into this and are training their own models at super deep levels. But it's really interesting to show that it's that HPC has been around for a long time. We've been working with the same systems. It's just carrying forward into new and novel ways. And so where do we really see this? We saw this in an example of like a federated AI platform for pediatric brain. How can we keep the data where it is, but still bring the learnings close? So here they were using, I think it was parallel cluster to kind of create the cluster for training. And what they were doing was learning on the data where it was and bringing it in to that central point because of data residency requirements. So none of these institutions, these 19 hospitals worldwide, had enough data on their own to train a model. But when they got together and brought the data together, brought the model together in a federated learning approach, they were able to achieve 88% accuracy. And that's only getting better because they are improving the model. So they were able to predict pediatric brain cancer, and then they were able to expand it, and they're looking for new ways to help children to identify pediatric brain cancer like before it really becomes cancer, because there's some hypotheses about that. But it's really amazing how it got down to like what kind of cluster do you use? Or in this case, they used EKS. Like, how do you bring the data and the cluster together in order to be able to map a model? We also have evolutionary scale. Evolutionary scale created ESM, in this case, it was ESM3. The amount of data the amount of data was, it's like 3.8 billion years of evolution, right? They trained on um, 1 time 1024 flops and 98 billion parameters. They built a cluster on AWS. They trained this whole model on functional protein folding. And so people are using it in order to identify novel drug candidates. This is what people are thinking about in their areas. It's all bundled by the data and the HPC on top of it to train. If we go to the next level, which is a little bit more abstracted, we're talking about how do you build these Gen AI applications that can take advantage of LLMs, take advantage of agents. And that's why almost every cloud service provider has this way of interacting in an easy way with an LLM and add parameters, usually via API calls. And so you can build applications around it. And so ours is called Bedrock, right? So you have model choice. You can choose the LLM that you want. So we have lots of customers building their customer-facing applications where they can choose the model they want. They can test the responses. They can test all sorts of different things and build the best customer-facing applications for their customers. And it's an easy way to experiment. It's an easy way to test different models. And so that's why we look at we very often, for that first level of playing, many of our customers turn to experiment with Bedrock. But I know you've been spending the whole week, or you're spending the whole week looking at agents, and I just want to highlight there's an industry-wide focus for creating agentic systems. I'm on industry-wide calls. We have customers in automotive. We have customers in games. We have customers in global financial services. They're all creating agentic ecosystems within their walls. The question is, how are they doing it? What decisions do they make? What system are they using? And so we're seeing all of the partners, all the companies that are servicing our customers as well, all building agents to try and make using it very easy. So this is changing the way people are doing business. Almost everyone I talk to is like, oh, we built the chatbot, so it's easy to explore the data. They're adding agents into their GUIs just to make it easier. And you can see this everywhere. On Amazon, we have Rufus, right? You can tell Rufus what you're looking for, and it's going to find those items for you and give you suggestions, and it'll summarize the reviews for you. So everyone's building these in to make it much easier, and it's much easier for you to use their systems, which hopefully ends up you buying their systems or buying what you need to buy. So you guys all know this. What are AI agents? AI agents are autonomous software systems that leverage AI to reason, plan, and complete tasks. They think iteratively, they evaluate the results, and then they do the next step. I like to think of these, especially if I build agents, as a set of tools where you're using the centralized LLM in order to reason between them on what you want to do, such as you might be like, I'm interested in identifying, I'm interested in the latest research on non-small cell lung cancer. Can you find me papers on the latest identification of biomarkers? And you can have an agent that goes to PubMed, fetches the latest abstracts or papers, brings it inside, summarizes it for you. You can interact with the paper through the LLM. And then it allows you to kind of assimilate that and make decisions, be like, oh, this one's interesting. Do we have any drugs that kind of target this receptor or this target? And you can make decisions based on that in real time. And so that allows you to kind of like fish through what could be infinite amounts of data. And we have customers doing that right now. So I'm going to highlight what sets them apart, right? They're intelligent, they can reason and act, and they can access internal data if you set the right permissions. And agents have the ability to use tools at the other end. And that's what really makes them special versus LLMs. So why do we see this? Like, agents became the hype probably in the past few months. What's making that hype, right? The reasoning capabilities are getting better. The scalability is getting better. The security around data, the cost of compute is coming down, and the ease of developing tools. But when you build it at scale, what really happens? When you build it at scale, what you start to see is sometimes there's a steep learning curve, identifying how they work, what's the reasoning, what's the right prompt. Um, how do we protect our end users from false information? What how do we interact with it? What kind of reasoning is it doing? Does this make sense? All of these, all of these things really kind of make people nervous about working with agents. And there are ways to do that, right? You show the reasoning, you let it be verbose. And it can kind of describe to you what it's doing and why it reasoned to use this tool instead of this tool. Um, at some point, it is an LLM. The LLM is making the choice, and we don't understand how it's traversing its internal network in order to make those choices. But what we can do is ask the reasoning why and see how it is. There are papers out there that you'll be like, the reasoning that it gives is to make us happy. We don't actually know if that's what's going on, but it's a very interesting problem to discuss with people as they build out more and more complex agentic systems, what they're using to kind of create guardrails in order to make sure that it's not hallucinating, it's not giving bad information, because what you in at least in the healthcare and life sciences industry, what you don't want is to set you down a path that's going to either spend lots of money or hurt a patient. And so there's a lot of interest in how do we control these pieces of information and these agents within the boundaries of safety and compliance. So the the agents have evolved over time in the healthcare and life sciences industry. We started with an era of Gen AI assistance. Hey, can you find me on SharePoint the latest data for this experiment, right? Or summarization of patient exams, summarization of reports, generation of based on historical clinical trial documents to build future clinical trial documents. So this is achieved with like a singular goal. You do one thing, you have a set of data, it's just giving you and feeding you back information, right? So now what we're doing is really moving into agentic systems. This is a world where you're leveraging intellect and multi-agentic systems to make complex decisions and coordinate and hopefully coordinate effortlessly, at least with the agentic systems I've played with. It takes time to build through it, but the idea is there's still very often there is a human in the loop, at least at the front and end. But the idea is the amount of human oversight goes down as you move across these types of systems. Um, and so there are lots of different pieces. I'm not going to go into this eye chart, but there's lots of different things to think about when you're building agentic systems. Some of these you always have to think about, like orchestration strategies and multi-agentic systems, but other things you might not need to worry about so much. Like, do you need an MCP server? Do you need flows? Are you going to create like supervisors in with an access to only a subset of systems? But these are different pieces that different customers need depending on the complexity of their agent systems. So we have another example from Eli Lilly, right? How to gather insights on real world data and literature. We have other customers looking about that and building new reports around real world data or clinical files that they have. And so what it does is it can turn these literature searches, like it can become minutes versus weeks of searching, finding the right paper, throwing out the wrong ones. You can much more easily make quick decisions about where to spend time on what papers. And so it's easy because it's natural language. You can automate, because if it's built right, you can like create patient cohorts, connect to internal databases. And the best part is, especially for healthcare and life sciences, full auditability and traceability. You know every action that's going on by these agents because it's recorded in logs. And the idea is to take the onus off of the time consuming work and let them spend their time doing the important work. And finally, we have users, right? We want to interrogate knowledge bases. We want to build code. We don't actually need to build models or applications. We are building applications or we're building code bases. And so we might build dashboards. We might want to say, build a whole script for me that does this, build a SQL query that'll help me access the data that I need and structure the data that I like. It'll take minutes as opposed to what might be, a half hour to a few hours to days to weeks. There are environments now that help groups of coders make sure they work together, and have everything aligned to write code principles, make sure everyone is working together and consistently. And so these are only getting better with time, and it's moving incredibly fast. And so, for example, there are going to be announcements we have a New York summit next week. There are going to be a lot of announcements about new services for Gen AI that my whole team is going to be like reading about furiously because our customers come to us to ask questions. So this changes fast. It's changing fast for our customers. It changes fast with the number of companies that are helping this and then different ways. The different types of models, the different types of applications, the different um, types of very tuned agents that are coming out. And so keeping up with it is also hard. And so we have different types of agents that can help across an organization for developers and IT professionals, right? You can ask questions about the services themselves. You can debug and optimize code. You can accelerate development. You can debug errors and figure out why this error is happening. And you can basically lift one application in like one version into other versions. So the idea is you're not spending weeks and months. This can be done in a matter of days with a very robust time frame and security around it. For business users, they might not know any technical coding skills, but they want to be able to quickly build dashboards so they can see what's going on, tap into enterprise knowledge bases, understand the impacts of the way their businesses are going, and also like help people solve their problems for their customers, like in a contact center or call center. And so we saw this at Bayer. They basically spent time implementing Q Developer for all of their developers. They saw, if you think about the bell curve of experience in coding, there's a big middle. Who are the ones that get the most benefit? The people that are new to the code base, the people that are new to programming, those are the people that benefit like right out of the door. And we saw this consistently talking with customers. But surprisingly, who's the other end of that spectrum that gets the most benefit? It's the people at the top. Why? Because they're using QCLI or they're using whatever that LLM. It's like getting in a room together with your other really experienced coding buddy and whiteboarding and testing and really using it to run those thought experiments in your head. So when you're building something new, sometimes you need that person to bounce those ideas off of. And they're using stuff like QCLI to do that. And so we saw this internally at AWS, and there are ways, and we see it at other customers as well. That middle portion, it's gotten a lot faster than I heard this from my customer, but they used to say it's too slow for my experienced coders. And so they just get frustrated with it. It's a lot faster now. And with the agentic forms of it, it's become even easier. So like Bayer did it, they saw improvements of 75 to 80%, and they decreased technical debt super quickly, which ultimately like reduces the bottom line for running, and then they have more money to do more interesting work. So there are a lot of lessons learned, right? One of the questions that we get a lot is how do we manage hallucinations? And the truth is they're going to happen. It's just a matter of time and probability. So you could ignore them, but that means you have to have a human to decide. You have to have a human to decide it's important or not, right? So many of us are putting humans in the loop, at least until we feel comfortable. But really, if you think about it, eventually it will hallucinate, and maybe or maybe not that human will be there. So how do we reduce those probabilities. So there's reflection patterns, there's LLM as judge, there's ground checks, where you can kind of set barriers to be like, if it comes back with information like this, don't let it out. Or if you have personally identifiable information, be like, don't show this on a screen. We can use automated reasoning checks. Like these are things that we can implement to kind of manage the hallucinations. And so we're seeing customers experiment with different types of these guardrails in order to achieve their goals around Gen AI. So you also need to make sure that all your data is kept private and secure, and that none of your data goes to train your underlying models. This is really important for many of our customers, and we don't want it to leave the cloud. And so customers create their base foundation models with Bedrock, and then you can create customer specific data to train, and that becomes your foundation model. And so these are private to you. And so at Amazon, your models are your models, and you can kind of create those models and use them at your will. We're just here to help. And finally, operating Gen AI at scale. This can actually be complicated at times. And so what we have is you kind of build your best practices around it, right? Build, test, deploy, operate, start again, and then improve. And so there are lots of different ways to do that. How do you pick the right project? What are people trained? How do we prioritize the business value, right? All of these, but it really comes down experimentation, do a POC, get feedback, and improve that. And so what many of our customers are doing is they're kind of looking at AI centers of excellence to sort of like feed this innovation center to around generative AI. And finally, we can talk about some best practices and takeaways. Generative AI is evolving super fast. You need to kind of keep that in mind. You should have strategies that adapt as new things come out. Hopefully, you haven't built something so brittle as things that when it comes, I can't change it. It happens. We're in a very fast-paced area, but like you need to keep in mind that this is a very fast-paced time around Gen AI, right? Define your use cases. The more specific, the narrower, the easier it is to build something and at least test your ideas if it's worth investing. Sometimes the one person put it to me like Gen AI can get me to the pre first draft. If I have to put the same amount of work into fixing that to get my first draft, it's not worth using AI. I can just write that first draft myself. So really define and think about what's important when doing when working with generative AI in your proof of concepts. Again, data's foundation, building the data foundation so you can accelerate through different AI proof of concepts is really key. I've seen it accelerate at customers, and it really is going to differentiate each customer from each other. You can already start to see who's leading packs and who's not. Try and use managed services to take away the grit of like managing the infrastructure. So we try and help our customers do that so they don't have to worry about managing the infrastructure to build things. It's surprising if you haven't played with different models, different prompts, and different feedback, they have personalities. Model choice is really critical. People have preferences for models that they use for different types of workloads. And it can even be version dependent. So there are also different costs for running different models. All of this plays into your decision making. And finally, and most importantly, especially in the healthcare and life sciences, where we're dealing with compliance systems, governance is key. It is key to protect data, protect patients, protect the environments around, because ultimately our goals are to help patients. There's very often PII or private information, whether it's health or personal information. And so we need to keep those in mind. And so we work with our customers day in and day out to making sure their systems are secure in order to protect fundamentally the patients who are at the core. And so I think I'm pretty much at time. I am happy to take lots of questions, and I gave you lots of information. So thank you.
Yeah, thank you so much, Ariella. Thank you for this very insightful presentation and those tips that are really, really very informative and exciting. So we have time for questions. Do we have questions online first, maybe? Yeah. Here is one question from Crystal. She says she saw the possible reduction of human oversight by using AI tools. Have you estimated how much can this help the current research crisis of reproducibility?
So a lot of reproducibility. So that's a really good question. Hold on, let me think about this. The key to reproducibility is going to become like identifying the data sources, identifying the algorithms, and keeping track of what they are and being able to do that. So agents, remember, they're not deterministic. And so that's where we can see problems arise. But that's really where the logs come in and the tracking of all those pieces. Because what you want to do is identify this chose to do this and then do this. So you could rebuild what was done by tracking the logs and keeping really good track of that type of information and storing it along with either the models that were built or along with the analysis that that agent did. But remember, agents do things. Either they call an algorithm or they run a query or they go and fetch something. And so a lot of business logic isn't necessarily, it can be built into the prompt of the LLM, but very often the agent can be deterministic, right? Unless it's running its own model. But then what you can do is this is where best practices come in, right? Or even around CI/CD about model building. This is where checkpoints come in. This is where versioning comes in. Part of the biggest problem of reproducibility is people aren't doing those best practices of keeping track of their code. What happens is 6 months later, they're like, ah, man, what did I run on this? I've been running this, but I don't know. So like if you keep track of your code commits, if you keep track of your Docker containers, those are best practices just around computing in general. And if you align that with the code that you create around papers, it becomes a lot easier to reproduce the data. So a lot of it is about just doing those best practices that I know I've run into people where I don't always do it, but in cases where it's really critical and you need to really identify what it is, it's really important. Like I know there's a company where they didn't do this, and the analysis that was submitted to the FDA for 5 different drugs, the person left, they didn't know what analysis they did, like it wasn't there, it wasn't documented anywhere, and they had to pull all 5 of the drugs from the FDA. That's a huge hit. So it's not just about it's about those best practices. Reproducibility is key to being able to do things over and over again and understand also if I change things, how does this change the LLM? How does this change the weights? How does this change what it does? And so we're talking about version prompts. We're talking about different ways to keep track of all the data.
Thank you, Ariel, and thank you for the question, Crystal. Do we have any questions here in the room? Does anybody wants to ask a question? No? Don't be shy. Yep.
Thank you for the great presentation. So this technology is new for me, and I am so excited learning about that. But my concern is still is on the publication. So I know that PNNL has a lot of private information, high performance computing. But we are going to return this weekend to our university. As a student, we don't have access sometimes to that kind of technologies. What is the recommendation about that? And if we use open source AI, I am afraid that we are going to generate an output that could be probably we don't feel confidence to publish. Do you know, did you catch my point? So if I can feel confident to use the AI to work in my research, and when I wanted to publish, I have to feel confidence that I will not have a lawsuit
Yeah.
because plagiarism. Do you know?
Yeah. I know
What
what
is
you're
your
saying.
recommendation?
This is why some of the models aren't being released in Europe. um, so this is actually a really good question. We had this question come up in even around proprietary data, right? If you give proprietary data in a federated way, how do you guarantee that AI agent isn't going to just regurgitate someone else's proprietary data? Open source tools, there's some very good ones, and there's some ones that that are questionable. Always do your due diligence. Look at the work, look at the code, see what it is. Both, Anthropic, AWS, a lot of the cloud providers are offering open source frameworks in order to create agents, right? Anthropic's doing MCP. AWS has built Strands, and offering it to help people build agents. Like someone on my team is new. She spent like, I don't know, 3 months building a couple of agents, and she built it in 15 minutes using Strands. Knowing where the code is coming from, if there's a paper around it, that can add a little bit more trust into using open source software. Especially if you're generating custom code, right? I would say know where your open source software is coming from. There are companies that will never touch open source software, but there are many that will and adapt it to their own workflows as well. Remember, at least when you're generating agents or using the code developers, what they're doing is they're not regurgitating the code, they're regurgitating code in a way that you're going to use it. So they're using the best practices of Python, they're using all of the whatever language you're using, they have all that documentation in order to develop what you need to develop. And so I would keep it, I keep it there. Be very careful. I will say, you guys, many of you are going back to your universities and they're in academic settings. At least for me and many of my customers, we have to be very careful of the licensing. There are certain licenses where commercial entities can't use it, but academic entities can use it for free. So these are all things to keep in mind when you're using it. A lot of it is due diligence, but very often, if you can work in a secure space and you trust where it's coming from, you can test in small environments. Like there's a lot of testing I do locally before I might blow it out on my MacBook, before I blow it out into a cluster. So there's a lot of stuff you can test on your system and then move it into bigger systems in order to actually use it either in production or in more testing environments. I don't think there's a hard and fast rule. Like at AWS, what we do is if we really can't let data get out, we don't give it access to the internet, right? Whatever's working, whatever training is going on, it can be done in an account without any way in or out for data streams. And so that's how we can protect the data there. It almost becomes like a black box. A lot of it is just do your due diligence. I don't know what you're going to go back and play with, but there are very trustworthy sources where you can go and take code and play without any impact to your network, to your school's network. It can just stay on a local computer and you can kind of gain the experience that you need to.
Thank you.
Thank you. A follow-up question. Do you have academic customers? And
Yes.
would that be affordable for research, academic research? Can you talk a little bit more about that?
So we work with governments, we work with AMS, academic medical centers, we work with universities, we work with everybody. There are a lot of ways we can make it affordable. There are grants that you can sometimes get. There are ways to work with Amazon. But the key is what we want to do is HPC is like probably the biggest problem. We charge for usage of services. So like you spin up a server, you don't shut it off, you pay by the hour. The key is really being mindful to shut things down when you're done, because you can have an account that runs at 0. As long as you spin things up and spin them down, you'll just spend for the minutes or hours that you're running. But we work with everybody, and there are different ways. There's different ways that we work. Some of them we work on heading up their like HPC in the cloud. Some of them we work on some of their bigger designs. Like as you saw, the Stanford project was with an academic medical center. They trained a model. Sometimes we work with different universities and we get credits from different service teams to run interesting things, or we can find partnerships. There are ways to do it. What I would just do is just AWS has some free services, and it has like a free tier which you can explore. But just be mindful to shut things off afterwards. But yeah, we work with everybody. And some of them are very small projects that are not very expensive, but some of them are very big, like running big HPCs.
Thank you. Do you have any recommended publication for the students that talks about comparing like authenticity of AI agents or reproducibility?
Let me see what I can find. I had a really interesting one I posted on LinkedIn about the chattiness of agents from Anthropic. So if you look up my name on, I think it was like one of the last things I posted, about like an agent is very chatty, but like an agentic system is extremely chatty. And actually that's interesting because it increases the price because it's token. If you think about it, in AWS, we charge by the amount of tokens we pass an LLM. And if you have agents talking to each other through this centralized LLM, they're just passing tokens. And so I think the number was like 15 times more tokens or something. But that was an interesting paper. I can try and find some papers around reproducibility and comparing. I'm just taking a note down.
Yeah, thank you.
And what was the second thing?
Please take your time.
Reproducibility and
here it says authenticity with human lead. So maybe it's talking about human in the loop.
Yeah. So I will say we have customers that do this, and what they kind of do is set up, at least for the authenticity and reproducibility, they have tests that they set up to make sure it's getting at the right information that people want. And so, especially when they're going to provide it to their customers, they do a lot of testing to make sure like that box is bounded and they can trust the output that comes out. And a lot of this comes from prompts, and what they end up having the agent do is like filter the output through something else that helps shrink like bounds the box before it goes back to the LLM. So let me see if I can find some papers. Hopefully I can, and I can share them.